This is REKHA RANI from TSRJC LINGAMPALLY. This is the third session from the 4 sessions. Today I am going to teach about the third session of the atmosphere. Here we already discussed. Just we have to quickly recapitulate the whatever we have learned so far. In the introduction part, we have learned about the air is a basic component of the Earth's surface, and it forms the important component of the atmosphere. Okay, and it has the important gases like oxygen, carbon dioxide, nitrogen, argon, and other gases. The oxygen and nitrogen are the important gases. Nitrogen forming the largest part of the atmosphere, and oxygen is an important gas which is useful for the life on the earth, life survival on the earth. And the carbon dioxide, madam, join అయిపోయాను రావట్లేదా జాయిన్ వచ్చింది మేడం నేను చెప్తున్నట్టు స్టార్ట్ చేస్తాను ఓకే సార్ So the main important gases we already discussed now, and atmosphere helps in various activities of the human beings like the flying of the hot air balloons, jet planes, and launching of the satellites, and etc. We had the different climatic changes due to the presence of the atmosphere, that is variation in temperature, rainfall, humidity, moving of winds, ocean currents. And also we are able to grow the crops and the food crops and whatever we are having now is because of the atmosphere. And now we are having the composition. We already discussed this composition: oxygen, nitrogen, xenon, krypton, helium, carbon dioxide. These are all having just one part of the atmosphere, apart from the oxygen 21% and nitrogen 78%. And water vapor is the we are having the water vapor at 0.4%. But it also plays an important role in forming of the clouds and from where we are getting the rainfall. The dust particles also have helpful. Then structure of the atmosphere. Based on the chemical composition, temperature and altitude of the atmosphere is broadly classified into atmosphere, homosphere, and the heterosphere. This homosphere again classified into troposphere, stratosphere, and the mesosphere. And heterosphere is again classified into thermosphere and exosphere. Homosphere extends up to a height of 90 kilometers, and it has important gases like nitrogen, oxygen, and carbon dioxide, argon. And it has important 3 layers, that is troposphere, stratosphere, and mesosphere. In the troposphere only, we had in the homosphere, troposphere, stratosphere, mesosphere, and in the heterosphere, thermosphere, and exosphere. In troposphere, we have it is the first layer of the atmosphere, and we have all the weather conditions took place in the troposphere itself only. And the second part of the atmosphere is the stratosphere. In between the stratosphere and the troposphere, we had the tropopause. And next is in this tropopause, we had the ozone layer, which is important for the life on the earth because it protects the ultraviolet rays coming from the sun. And we already discussed this, the important parts. This is mesosphere, thermosphere, and ionosphere, which is also plays an important role in the atmosphere. And exosphere is the outer space of the atmosphere, and it is where the temperature may reach up to 1500 degrees. And in this layer, molecules and the atoms escape into space. This is the outermost layer of the Earth's atmosphere. Now, and in the second session, we have discussed about the air pressure, which is a force exerted on the surface of the Earth by air due to gravitational force. But it is nothing but the air that we have spread around all us. We feel sometimes, and we have seen sometimes when we feel it is just like a breeze, and when we see or saw that it is like a cyclones. When the cyclones happens, we have the air is blowing. So it is highest at the sea level and lowest at the land. It is measured with the help of the barometer. It is you can see here in the pictures that is the older barometer and the newer barometer. The newer one is the mercury barometer. The factors affecting the atmosphere, air pressure is the temperature of air, altitude, and density of air molecules. And we had the low pressure has developed around India and also in the equatorial regions where there is a high temperatures. And where is the high temperature and elevations, we have the low pressure has developed. And this low pressure is always associated with the cloudy skies, wet weather, and cyclonic flows. And this low pressure is mainly developed due to the Coriolis force. There is Coriolis force is nothing but the movement of the Earth on its axis. In the northern hemisphere, it is anti-clockwise. In the southern hemisphere, it is clockwise direction. Okay, and we had this low pressure is mainly important for the development of monsoons over India. And high pressure, it is developed in the air, and when it loses its energy and air molecules become closer and become denser, thus showing the movement of the air. As a result of the cool air descends and sinks down to the earth due to the gravitational pull, thus creating high pressure. It results in dry and fine weather conditions with clear sky. Large diurnal change of temperatures are there. We can observe this large diurnal change of temperatures at night, and also during the daytime, when there is a greater sunshine is there in the daytime. It mainly took place in the temperate regions and the polar regions. We also had the pressure belts. The pressure belts also played an important role, which flows over the surface of the Earth in the horizontal directions in the Earth's atmosphere, just above the Earth's surface. It is mainly due to the seasonal and the spatial variation of energy, which is received by the Earth at different places. In different places of the Earth, we receive these pressure belts in a continuous manner. Okay, and when it comes to cooling, land cools faster than the oceans. Why means? Because the land has a lesser area compared to the oceans. Oceans are the larger areas. They took time to observe the radiation coming from the sun. So it cools down. It cools down very slowly, and it observes the heat also very slowly. And the tropical latitudes receive the most intense intense amount of solar radiation and hotter than the temperate or the polar latitudes, because you can see here the rays why the tropical latitudes are receiving the higher amount of sun rays or insolation means because the sun rays are directly falling on the Tropic of Cancer and Tropic of Capricorn, both on the tropics, because it is the Earth is tilted. Due to the tilting of the Earth, the rays are directly falling on the tropical regions, not on the equator. Okay. Now we had the winds also. Winds, we have the winds are nothing place we are that are moving from higher areas, from high pressure areas to the lower pressure areas. And we had the different types of winds, that is breeze, gust, and storm. According to the movement of the wind, we call it as a breeze, gust, and storm. And the types of pressure belts, we already discussed this in the last session. The 4 major pressure belts of the Earth are equatorial low pressure belt, subtropical high pressure belt, and subtropical low pressure belt, subpolar lows. Equatorial low pressure belt extends from the equator to the 10 degrees north and south of the latitudes, and where the sun rays are falling directly on the equator throughout the year. The sun rays are falling directly throughout the year, whereas because of this, there is high temperatures on the equator, not on the equator, but on the tropics. And here we have that due to this high temperatures, the conventional currents rise. The conventional currents is nothing but the warm air, and they are thereby producing the low pressure area in the equatorial region and in the tropics. And because of this high temperature, there is no horizontal movement of air, only conventional currents are formed, and there is nothing but the doldrums. And due to this convergence of the winds, blowing from subtropical high pressure. They are the winds which are coming from the subtropical, the winds which are coming from the subtropical high pressure high to subtropical lows. We had this sea here. We had the this winds are converging both at the equator region. This region is called as intertropical convergence zone. This is an important zone which help in the formation of the monsoons over India and in the southeastern countries also. And subtropical high pressure belt, this has formed extends from tropics to 35 degrees in both the north and south and hemispheres. It is mainly formed due to the rising of the air currents of the equatorial regions deflected towards the poles. When the currents are deflecting from the equator to the poles due to Earth's rotation, these belts are formed, and they are, after becoming cold, they become descents, or they become pulls down towards the equator and gather here, resulting high pressure. Subpolar low pressure belt. Here you can see the pictures. Subpolar low pressure belts are formed at the Arctic Circle and the Antarctic circles. In the northern hemisphere, Arctic Circle, and in the southern hemisphere, Antarctic circles. This converge to produce the cyclonic storms on low pressure conditions, and this zone is also called as polar front zone. Here you can see this. Here polar front zone. Here mid-latitude jet streams are formed here. In this area, we had the polar front has formed. Subpolar high pressure belt, the region extending from 66 degrees to north and south pole, and the sun rays in this region are very slant. They are slant in manner due to the low temperatures. Because of its compression and density of the air increases, high pressure is also increased. Here you have the high pressure because the rays of the sun are slantly, they are very slant, and as you have seen in the earlier image, that the rays of the sun from the sun, the rays are always slantly falling on the Earth's surface near the poles. That's why here we had the always the temperatures are low and it's compressed. The winds are compressed, and the winds blow towards the subpolar low pressure belts. And we had found the polar vortex also here, where the high dense cold winds prevails. And coming to the present session now, this is in the chapter 4, atmosphere. We had the present session, third session, winds. Coming to the present session, we had the winds. These winds are nothing but, just now I explained you, the winds are nothing but the flow of the air from high pressure area to the low pressure area. And these winds are classified based on the global and local phenomena on the Earth's surface. They are named according to the direction of the wind. I already told you the winds are blowing from high pressure to the low pressure area, and sometimes they blow from the east to west also. That's why they named in different names according to the direction of the wind blow. Okay, then now we are having the different type of winds. They are the planetary winds, primary winds, secondary winds, and the tertiary winds. These winds, we had the primary winds, that is nothing but the planetary winds. These winds, planetary winds, are the permanent winds. And the secondary winds are the seasonal and the periodic winds. In the secondary winds, we had the monsoons, which are developed over the Indian subcontinent and the Southeast Asian countries. And the tertiary winds are the local winds, which cause nothing but the small local winds, which covers the local areas only. Example, some Chinooks, winds like that. So, primary or the planetary winds, we shall discuss in detail now. They are present on the surface of the Earth throughout the year in the same direction. And therefore, they are called primary winds or the permanent winds and the prevailing winds. You can observe here on the image that the primary winds or the permanent winds are blowing throughout the year here. They are throughout the year without the seasons. They blow throughout the year, but due to the changing of the seasons and the insolation coming of the solar radiation, the speed of the winds or the maybe changing, the intensity of the winds may be changing, and the direction also slightly shifts. These winds are in the form of large air masses, We already discussed what is air masses now. Subpolar air mass. This is formed mainly. This winds also formed, and these winds are there in the atmosphere that are around the Earth's surface, in mainly due to the gravitational force of the Earth and also due to the Coriolis force. We already discussed about the Coriolis force. What is Coriolis force? Just now I mentioned it. Okay, and these winds are in the form of large air masses formed due to the Earth's rotation along the shape of the Earth. I just now told you that the Earth's winds are formed in the form of the air masses around the Earth. Means they are blowing in the lower layers of the Earth. Okay, and then this is also formed due to the heating power of the sun. And these winds also blow from one latitude to another latitude. See here, the winds are blowing from one latitude to the other latitudes. The winds which are blowing from the tropical regions towards the equator, and from the equator tropical region to the temperate region from polar regions to the again temperate regions. So here in the southern hemisphere also, the same thing happens. So the winds blow from one latitude to another latitude due to the difference in the air pressure. This is mainly due to the difference in the air pressure because of the insolation we received from the sun. So these are known as the planetary winds. These planetary winds are mainly controlled by the latitudinal pressure belts. Just now I told you now, these are due to the control by the pressure belts. We had the pressure belts also. We discussed in the earlier class that we had the pressure belts. That is equatorial pressure belt, subtropical low pressure, high pressure belt, subtropical low pressure belt. Okay, these planetary winds are mainly controlled by the equatorial pressure belt, subtropical high pressure belt, and subtropical low pressure belt. And these winds cover larger area of the continents and the oceans. Here you can see it covers most of the Earth. It covers almost all the Earth. Okay, so it covers larger area of the continents and the oceans. These winds are deflected towards right in the northern hemisphere. It is deflected towards the right, and here in the left in the southern hemisphere. Winds generally blow from east to west. They generally blow from east to west rather than from north to south. They are not just blowing from north to south, but they are blowing from east to or west like this. And the areas in which the winds which are merging from the north to south or south to north, they are merging here in between the equator. They are called as intertropical convergence zone. There are nothing but the convergence zone. Then this zone helps in the formation of the monsoons. We had the different types of the primary winds, that is the trade winds. Trade winds are also known as the easterlies, as the winds blow from the east. They are blowing from the east towards the west. Here you can see the intertropical convergence zone, and they are blowing towards the eastern direction only. You have the Hadley cells here. Also, high latitude cells, they are the cells. The air is packed in cells. So these are called as cells. We had the Hadley cells, Farrell cells, and the polar mid-latitude cells and the polar cells. Okay, it was studied by the Hadley. That's why they have given the name of the Hadley, scientist Hadley. They blow. They are also known as easterlies, as the wind blow from the east. It is a belt that lies in between 5 degrees north to 30 degrees north in the northern hemisphere. See here, not on the equator. These winds are blowing towards from 5 degrees to the 30 degrees, and here in the southern hemisphere also 5 degrees to the 30 degrees. So in both the hemisphere, they are blowing 5 to 30 degrees. They blow from the subtropical high pressure to the equatorial low pressure. See here, you can see the direction of the winds that are blowing over the subtropical high pressure belts to the low pressure areas. This is the equator is a low pressure area, and they are blowing from the equator to from the polar region, temperate regions to the equator region. They are descending. They are just descending, coming down to the equator region. In the areas of the origin, the winds are stable when they are origin. They are stable and drier in the Eastern Ocean than in the Western Ocean. When they are coming from the Eastern Ocean, they are stable, and in the Eastern and the Western Ocean, as at the equator, they are warmer and humid in nature. Here they become warmer because I already explained you, due to the insulation received by the Earth here, due to the rising of the conventional currents, these winds are calmer, warmer, and humid. It has a high humidity in these areas. Okay. The winds that blow to the south, north to south in the northern hemisphere and south to north in the southern hemisphere, it is mainly due to the Coriolis force and Paris law, and because of this, the winds got deflected. We already discussed this point also. The everything that all the air that are blowing or moving around the Earth's surface is mainly due to the Coriolis force and the gravitational pull of the Earth. The atmosphere also intact with the Earth means it is mainly due to the gravitational force or the magnetic force of the Earth. Now coming to the westerlies. These westerlies are the prevailing winds, and these winds blow from the west to the east. Here you can see in the image on the picture, they are blowing from the west to the east. And they blow in the latitudinal belt of 35 to 60 degrees and north, and 35 to 60 degrees in the in the south. These winds are blowing from in the northern hemisphere and in the southern hemisphere also. But in west, the direction is, you have to remember this, the direction of the westerlies is, why they got the name is means they are as they blow from west to east, they got the name as westerlies. And these westerlies are also called as anti-trade winds. We already discussed about the trade winds. Here, this westerlies, the trade winds are blowing over the equatorial region, the tropical regions. But these westerlies are in the temperate regions. This 30 to 60 is the temperate region. You all know about this. You study this in the 8th and 9th classes. What is the temperate region? What is the equatorial these regions? Okay, so the westerlies are blowing in the temperate regions, and they are called as anti-trade winds. They originate from high pressure areas. See here, these are the high pressure areas. They are little bit far away from the equator and the tropical regions. And the rays of the sun is here, the slant, somewhat little bit slanted. That's what they have the high pressure. Because of the low temperatures, they have the high pressure. So these latitudes are also hot latitudes, and they are moved towards the poles. These winds are again moving towards the poles. The air streams that flow towards the pole from subtropical high pressure area deflects towards west in the southern hemisphere. They are deflecting towards the west in the southern hemisphere here. See, look at the image here. The winds are deflecting west to in the southern hemisphere to form the westerlies. And these westerlies are variable, but variable means they are changing in their wind force and direction, especially in the northern hemisphere, because they're always, because of the continents, they are changing in their direction. And they are very furious also. They are very faster in this region because the high pressure region, and because of this high pressure region, these wind westerlies are very furious and change their direction many times. And in the southern hemisphere, the western wind blows with the greatest strength in regular manner throughout the year over the oceans. Here they are also very fast and furious, and in the southern hemisphere, because it is free of the land. This southern hemisphere is free of the land. That's why the westerlies are blowing much faster than the northern westerlies, because it is free of the land and it is a vast ocean area. Okay, that's why these westerlies are blowing at a fast rate in the southern hemisphere. In the southern hemisphere, between the latitudes 40 to 50 degrees, they are called as roaring 40s and screeching 60s. Roaring 40s and screeching 60s means these westerlies are blowing at a faster rate in the northern and the southern hemispheres. They are called as, in the southern hemisphere, roaring 40s means they roar like a lion in the the sound of the wind roars like a lion. That's why they are called as roaring 40s and screeching 60s, means because they are the cold weather conditions. Cold weather conditions are prevailing in the the 60 latitudinal region. 60 degrees latitudinal region, they are called as 60s because here because of high pressure and the low temperatures, the temperatures are very low and we feel very cold weather conditions here. Now coming to this, the easterlies, one of the prevailing winds or the primary winds, we had the easterlies or polaris. They are the dry and the cold winds. They are part of the prevailing winds. Here you can see here we had the polar highs and polar easterlies in the northern hemisphere, and in the southern hemisphere also we had the polar easterlies. The cold air rises and subsides. Subsides will come down near the poles and it will settle down there. The cold air rises because the rays of the sun are very far away from this. It is slant. That's why they had the high pressure, very high pressure, and because of the high pressure, it has cold air. The temperature is very low, and it is subsides, means it will settle down at the polar regions. Okay, and they blow from the polar high pressure region, polar high pressure to the temperate. Again, from there it subsides and then start again moving towards the temperate regions and then towards the tropical regions and then coming to the trade winds. The movement of the air or this air pressure winds or the always moving from the north to the south, north to the tropical region and south to the tropical region and from tropical region to the north and south of the equator. That's why they blow from the high pressure, polar high pressure to the temperate low pressure belt towards the equator. They are deflected. Here you can see here towards the equator, they are deflected towards the west. They are deflected towards the west in the northern hemisphere. They are deflected towards the west in the northern hemisphere to form the northeasterlies, and in the southern hemisphere to form the southeasterlies. Here you can observe here also they had the Hadley cell, warm air, and again high pressure, low pressure near the equator region. You have the low pressure area. In the Tropic of Cancer, high pressure. Here again low pressure, and in the polar regions again you have the high pressure areas. Now coming to the seasonal winds, we had, and these seasonal winds are mainly formed due to the changing in the seasons or change in the direction of the wind at local days during the local times. Means today maybe you are having the some sunny weather, but immediately tomorrow you are having the cool weather, and this weather is mainly due to the changing of the wind's direction. Okay, these seasonal winds are the periodic winds which change their direction from time to time. It's and suddenly changes is the temperature or the weather conditions of that particular area. Example, you had the monsoon winds. Monsoon winds are the special winds that have developed over the India, and this land and sea breezes also the winds which have the blowing. These winds are blowing from the land to the sea and the sea to the land. Mountain and valley breezes. Mountain and valley breezes means the winds which are blowing from the mountains to the valleys and valleys to the mountains. So you can see here the seasonal winds are the example of seasonal winds. Also you have this different local winds are also there here. In the world map you can observe the different winds that are blowing over the earth. Here monsoon winds. These are plays an important role in our daily life, in Indian daily life or Indian life. These winds forms an important drive. They become the gamble of Indian economy. These winds or Indian agriculture is mainly the gamble. One of the agriculture scientists said that monsoon winds become the gamble of Indian economy because we Indians, agriculture farmers, most of the agriculture farmers mainly depend upon the monsoonal winds only. We have from the monsoon winds we had the monsoonal rainfalls, and from these monsoons we had our agricultural activities all the country of India mainly depends upon the monsoonal rains only. Our agricultural activities start with the coming of the monsoons. So these are also the seasonal winds. They change their direction with the season. According to the season, they change their directions. Here you can see here we had the during the months of summer we had the summer monsoons, and winter monsoons also we had the retreating monsoon, northwest monsoons, and the southeast monsoons also here. They also they always blow from cold and high pressure areas. They are blowing from the cold and high pressure areas. Means here you can see here the winds. This cold. This is whole is the ocean. Whole ocean is the surrounded with the Indian peninsula is the ocean, vast ocean area, and this ocean area is having the high pressure. We already discussed why it is having a high pressure. It takes a lot of time to get hotter. That's why it has a high pressure and low temperatures. And because of this, they always blow from the cold high pressure belts to the low pressure areas. These monsoons are formed due to the differential heating of land and sea of the tropical and mid-latitudinal regions. These monsoons are mainly formed in the tropical regions, not anywhere in the world. These monsoons are found, this developed only in the eastern tropical regions only, that too around the South Asia and Southeast Asian countries, these monsoons are developed. According to Foin, monsoon is a seasonal modification of general planetary wind system. We had discussed about the planetary wind system, that is, it is nothing but the modified planetary wind system. Here, the summer monsoon is known as the southwesterly winds and is characterized by high variable weather conditions along with the frequent spells of heavy rain. You had the southwesterly winds. We had the monsoon starts here by the onset of the monsoons we had by touching of the Kerala coast. So this from the Kerala coast, they have the changing of the weather conditions are very much there, because with the frequent spells of heavy rain means we had the rains throughout the India. Somewhere or the other place we had the rainfall. You can observe from the Kashmir to the Kanyakumari, or from the Arunachal Pradesh to the Gujarat, we had the rainfall. Any part of the India, one part or other part, we had the rainfall throughout the year. This is mainly due to the differential heating of the land and sea breezes. Here, mainly near the sea, we had this rains. We had much rains, and near the this low pressure areas. This is the low pressure area around the Saurashtra, Kutch regions. We had developed the low pressure area, and this again here in the Himalayan region we had the high pressure, and this high pressure you might have studied. You are going to study this in the detail in the 10th class again. The climate of India. You are going to study this about clearly in the 10th class. Okay, summer monsoons is known as the southwesterly winds and is characterized by high variable weather conditions along with the frequent spells of heavy rain. So we have the frequent means we can observe here and there we can see the rainfall. The winter monsoon is gentle drift of air in which the winds blow from northeast. The winds are blowing from the northeast region and is known as northeast winds. See here, the winds are blowing from the northeast, from the Himalayas to over the Indian subcontinent. They are blowing and coming again. They are merging in the Arabian Sea. So they are called as winter monsoons, and mainly due to the northeastern winds. Here, this map is again where the onset of the monsoons with different dates. During these different dates predicts the amount of rainfall or onsetting. We are reaching the touching of the rainfall through these dates. The India has rainfall through these dates. Next is the land and sea breezes. In India, we had the monsoonal rainfall mainly due to the land and sea breezes only, because we had the vast land but it is surrounded with the oceans. On both sides of the India, we had the Bay of Bengal and the Pacific, Arabian Sea, east and west, and in the south we had the Indian Ocean. And because of this, we had the movement of the wind always from the land to the sea and sea to the land. And this land and sea breezes plays an important role in the development of monsoons over in the Indian subcontinent. See, what is this? They are found mostly in the coastal region. They are mainly found the areas where they are very closer to the coastal regions. Coastal regions means they are very close to the sea, and they are formed during the day due to the thermal and the pressure gradient. Due to thermal means temperature and pressure is the air pressure between the land and the sea. So they are formed due to the differences of the thermal and the pressure gradient between the land and sea. Sea cools and heats slowly. We already discussed this. Sea cools and heats slowly because of higher specific heat, and land heats and cools rapidly because of lower specific heat. We had the specific heat or the rays of the sun or the conventional currents. Because of this, there is a difference in the heating and the cooling of the earth and the ocean. During the day, the winds are blowing from the sea to the land. Here, the winds are blowing from the sea to the land. Here, sea to the land they are blowing, and sea to the land, then these are known as the sea breezes. They are blowing from the sea to the cool air coming to the land during the daytime, and they are moving again into the ocean as a warm air. So they are called as sea breezes. And during the night and during the night, the phenomena reverse, means the warm air coming into the land and the cool air going to the oceans again. And this is the land breeze happens in the night times. We had the mountain and the valley breezes. In the mountain regions, here you can see in the mountain regions, this breeze resembles the land breeze. In the daytime, the valleys are hot compared to the mountains. Why the valleys are more hot than compared to the mountains? Because it takes more time to reach the warm air into the valleys. That's why it becomes slowly heated, get heated up, and then it releases the heat also very slowly. That's why it takes a long time to make it hotter or make it cooler also. So in the daytime, the valleys are hot compared to the mountains. Hence, the air flows upwards towards the slope. It flows upwards towards the slope from the mountain valleys to the mountains. They are moving as a valley breeze. Here, this warm air is moving, and the cold air is entering into the valley region. Here again, in the day, during the night time, the cool air enters into the valleys, and warm air rises up. So, because of this, we had the mountain and the valley breezes. They also helps in maintaining of the temperatures in the valleys and the mountainous region. Why? Because of this breezes, we also feel cool in the mountainous regions during the night times. Mainly during the night times, we feel very cool in the mountainous areas. And we had the local winds also. Local winds according to the local areas or according to the variation of the temperatures in the local areas. We can observe our temperature varies from time to time in the local areas, and because it is mainly because of the pollution or the dust particles or the human activities, and also mainly due to the movement of the wind, and this movement of the wind also influenced by the temperatures. Temperature, we had due to the pollution, we had the high temperatures in the local areas. In cities or the urban areas, we had the high pollution. That's why the winds are also changes very drastically, and it causes devastation also. Sometimes it causes sudden rainfall, sometimes sudden floods. We can see or observe the last year and this year also we had the sudden urban floods. And this floods is because of the movement of the local winds, which causes the rainfall in the local areas. And sometimes they are also got affected with the cyclonic depressions that is formed in the oceans, which are nearby the seas. They are And when the depression is formed in the oceans, these local winds are also got affected. And due to this local depressions, these local winds also brings rainfall. And sometimes because of these local winds, the urban areas also get flooded up because of the congestion in the concrete, the formation of the concrete jungles in the urban areas. And these local winds blow due to the local variation in the temperature and pressure and influence a very small area. Hot local winds raise the temperature of that area. We already discussed hot local winds. Sometimes it raises the area, sometimes it brings down the temperature. The cold local winds sometimes bring the affected area below the freezing points. Sometimes in the months of the winter season, you may observe sometimes in the morning we had a cool breeze is blowing over the area. Fog and the mist is covered with the local areas. And this is because of the local winds only. These local winds blow in the lower layer of the atmosphere, in the very lower layers of the atmosphere. Troposphere. This local winds blows, and the mountain and the valley breezes, as well as the sea and land breezes, also one class of the local winds, and they also influence these local winds. These winds respond to local pressure gradients set by upper heating or cooling of the lower temperature. We had the hot local winds. We had different local winds, hot winds. Sometimes we had the hot winds due to the differences in the temperature variation, and sometimes we had the cold winds also. And these are the hot local winds, the Chinook, Lou winds. The Chinook is the wind blows in the Rocky Mountains in the USA, Canada, and part of North America. Many people believe that the word Chinook means snow eater. This snow eater means the winds that are coming from the Rocky Mountains eats whatever the snow means. Eater means it. Sorry, what is it? Sorry. It melts down, the winds, the hot winds melt down the snow of the Rocky Canada and some parts of North America. That's why they're called as the snow eaters. And actually, it is a name of the native American tribe called the Chinook, people who lived in the region where these winds are observed. It keeps the grassland clear of snow during the must of the summer. Similar winds that blow in the Europe are called as foehn winds. So similarly, the winds are also blowing in the European region. They are called as foehn winds. They blow along the northern slope of these foehn winds blow along the northern slopes of the Alps, and this melts the snow, makes the weather pleasant, and helps in early ripening of the grapes. You may observe in the European regions, the grape vineyards are there. So these foehn winds help in the ripening of the grapes. And the next wind is the Lou winds. The Lou winds are the hot and the dry winds. They are the gusty winds blowing in the plains of the northern India. You can see here the winds. Here, in the Indian map of India. Sorry, in the map of India, you had this. You can see that the Lou winds are blowing from the east to west. And in the West Bengal, they are called as Kalapaishaki winds because they bring the dust. And see here, this is the whole dust. So they are the fast gusty winds that are blowing from the northern part of India, so northwest to the northwest to the northeast. And here in the West Bengal, they are called as Kalapaishaki winds. And because of these winds are blowing due to the low pressure is created during the months of May, and this low pressure is mainly helpful for the formation of the monsoons again. It may cause sunstroke to people. It will also cause great devastation to people. Because of this, it brings high temperatures in the surrounding areas. And another wind that is here is the Simon in Arabian Desert, Yoma in Japan, northwestern New Zealand, and are the examples of hot winds. We can have the Simon in Arabian Desert, Yoma in Japan, northwestern New Zealand, and so on. And other examples of hot winds. We had the cold winds also. The cold winds, one of the important cold wind is the Mistral. Mistral is the wind. This is the most famous wind that blows from the Alps over France. Here you can see this around the Mediterranean Sea. Around the Mediterranean Sea, the northern part. This is the Mediterranean Sea. Here also you can see this is the Mediterranean Sea. And this Mediterranean Sea, in the northern part of the Mediterranean Sea, you had all the cold winds that are coming from the polar region towards the equator. This winds, and this cold winds also helps lowering of the temperatures in the Indian subcontinent during the months of January through February, and sometimes till March also. And this winds is also helpful in the ripening of the wheat crop, the winds which are coming from the Mediterranean Sea. So most of the winds that are blowing over the Mediterranean Sea are the cold winds. And see here, the winds which are coming from the south, they are from the African region and the Saudi Arabian Asian region. They are the hot winds. Sirocco, Hamsin, Samueli, Kensa. These are all the hot winds. And the Mistral is a wind that blows from the Alps over France towards the Mediterranean Sea. It is channeled to the Rhone Valley. It is a very cold and dry wind. Another wind is the Puna. Puna, it is not the Indian Puna, but it is the wind, Puna wind, occurs in the South American region of the Andes. Over the Andes mountainous region, took place, blows over the South American continent on the Andes mountainous region. Here, and this is the cold local wind in the Andes region. Here, it also brings pleasant weather conditions in the local areas. Another wind is the Pampero. And Pampero is the colder polar winds blowing very fast in the Pampas region of the South America. Here also you can see here Pampas. These are the Pampas. Pampas are the trophic grasslands of the South America. So they are the polar winds. They are winds blowing very fast in the Pampas region and brings pleasant weather conditions in these areas. You see. And they are also the other winds are blowing towards the interior of the South American continent in different countries. And we had the Peru here near the Peru. We had the La Nina and El Nino is the wind. That is the hot wind. Actually, this is the La Nina and El Nino is hot wind. They also brings lot of temperature diversions or differences in the ocean over the ocean regions. And this hot La Nina and El Nino brings the hot weather conditions, but it surpassed or subsides the Pamperos, which is a cold weather, cold polar winds. Now we had the questions. Are you able to understand me? Everything is you have understood. I think you have understood everything. And now write down the questions on your books. Sorry, write down the questions in your books. And this is the questions. Write down the characteristics of the planetary winds. Second question, define land and sea breezes. Third, mention the important cold and hot winds. Fourth one is the write a brief account on seasonal winds. If you have any doubts about this, you can call me or you can ask your teachers. See again, I'm reading out once again. Write down the characters of the planetary winds. Second one is the define land and sea breezes. Third one is mention the important cold and hot winds. Fourth one is write a brief account on seasonal winds. Okay. Thank you.